Everyone, thanks for coming. I am Vaza. I am core researcher and CTO at Ethereum Labs. Thanks for coming here. I want to start with a question. Who knows about the concept of DAOs, decentralized autonomous organization? Raise your hand. Oh, a lot of you. Who likes it? Oh, a lot of people love DAOs. And me too. But you know what? Are you really happy about DAOs are managing actually? Well, let's look at the state of art about DAOs. Is really a DAO an organization managed by a team that, for example, collects preferences of the voters through off-chain tools, like for example, all the tools that we all know, like Snapshot, for example. Do you really think that the type of DAOs are really decentralized and autonomous? Because the problem is that in the 99% of the cases, they are not really decentralized because the teams has the keys to manage all the changes inside the DAOs, and they collect just the preferences of the voters. And so the team has special permissions to do what they want, and they can also bypass the preferences of the voters if you think about it. And nobody can do anything if you think. If the voters take the preferences, choose the preferences, and the team is not okay for the team, they could, for example, bypass the voters' preferences. And this is not how decentralization on Ethereum works, if you think about it. And because everything in Ethereum is managed by math. And where is the math in a decision of just a bunch of people managing the protocol? There's no math. So if there is no math in a DAO, where is the love? Where is the preferences? Where are the preferences of the users directly on chain? This could be a huge problem if you think about it. And this is one of the challenges we met. And we think that in Ethereum Labs, the best way to create DAOs, to create an autonomous organization, is to vote to let people execute code. So everything must be directly on chain, not only a poll, but then executing decision. And so the first challenge we had to figure out is what it was to create an ecosystem totally on chain that let the vote of the voters, the token holders, to be the protagonists of the decisions directly on chain for real. So this means that you don't have to be careful on what about the team does, because everything is managed by smart contracts, not for people anymore. And so we created a structure that can let people vote to execute code. But you know what? Even this is a problem in a decentralized environment. Because if you can vote to execute code, you can change a lot of stuff into the organizations on chain. And this is also a danger if you think about it, because changing everything could be dangerous for everybody. For example, manage the economy of an organization or whatever. So change everything inside an on-chain protocol could be extremely dangerous, because there are no common rules and no zero assumptions. So you could be also in danger too, and that could be a disaster, like the way a team can manage directly the organization. So, what could be a solution to bypass this problem? Is to have a bunch of preset choices that people can set when they create their organization. And all the organization could start, for example, from a preset model, clonable every time, through, for example, a factory concept, with some customizable sets that you can do when you create your organization. Organization must be close to changes, so what you see is what you get, but open to extensions. So this means that you can create an organization that runs with their own preset rules, and then you can create several organizations up in time, and people can choose where to go, in the new version or stay in the older version. But everything is ruled by math, 100% by math. And if you think about it, this is a pattern, let's say, a concept that we already have into Web 2 environment. For example, in the Amazon marketplace, you have all the structure, you just put your products and you can sell your products with your own rules, but the entire ecosystem, the entire environment is maintained and offered by Amazon. Or, for example, in Twitter, you can just post tweets with a limited set of characters, but nothing more, if you think about it. So, Twitter puts the structure, and you put the content. And this is what we created. We put the math, we offer you the possibility to create organizations, and you put what are your preferences to create your own. So, using our tools, for example, you can create your own platform with a versioning system. So, this means that you can create your own factories to let people create your platforms, and using a versioning system. So, everyone can choose what version of your platform to use. And once it is created and runs, nobody can stop it. We also created a system to let you create easily and a cheaper way a platform, because in the best cases, it's not about creating just one smart contract, but a bunch of smart contracts operating each other. And you can offer to the users the possibility to create everything you want as you design it, and they can just customize what they want. And the system of factories is 100% compatible with already existing platforms that you already created. And you don't need any code anymore if you want. For this reason, we created a bunch of tools for you for free, and we put them in a tool called SwissKnife. SwissKnife creates for you the most important tools you can use to create your own platforms, to let them be indexed and to be created easily for your users and versioned, of course. One of these tools, for example, would be the general purpose proxy. Everyone, I think, knows the proxy pattern offered by OpenZeppelin or whatever. And we created a version that could be compatible with already existing platforms and smart contracts. And we also offer the skeleton of a factory that lets you create and lets the people create your own platforms through factories. And then we also create the possibility to let you create your own factories through the factory of factories. And now I'm going to show you the code of what we did. So, let's see something. Let's start from the factory. The factory is just a smart contract that lets you have the possibility to have the deploy method passing the data of your user wants to customize your platform. and the smart contract does the magic for your users. It is overridable, so this means that you can provide your own logic, your own creation logic. For example, as I said, you don't have just one model to create, but several smart contracts that cooperate each other, and you can customize the logic, etc. What this simple line of code does, you just provide the rest of the model you have to create, and then the initializer will clone it and initialize it, and so the application is up and running in just one transaction. But you, of course, can customize this environment if you want. What does the magic for us? As I said, the general purpose proxy. We all know the proxy pattern by example. As I said, this is pretty similar on it, but it has a little difference. In the proxy, classic proxy pattern, you must provide the source code of your model that you clone, which must be the very first field inside your proxy contract. And every model you create must follow this pattern. So this means that the developers must follow the rules the pattern says. So if you have something already running, you cannot edit this smart contracts, or you must edit your source code inserting something. And this is the first change we made. If the model address in the proxy pattern is the very first field inside your smart contract, so it means that it stays at storage 0 inside the smart contract. It means that that field inside your smart contract must not be changed anymore. But if you have to store a variable through a store assembly API inside your smart contract, you have to provide at low level the number of your storage slot, which is 0x000, etc. The length of the integer, value is 32 bytes. What also stay in the 32 bytes? An hash, for example. So you are not forced to use the classic storage model inside Solidity EVM, Solidity and EVM. You can just save the source of your model address to a random number. What is this number? Is the hash of a word, for example. So not anymore save variables inside cardinality storage, but you can use the hash numbers, the hash converted in numbers, just to use that variable. So this means that, for example, in our case, we choose to save the model inside this value of the storage, which is just the hash of the word source. This is a really big number, and there will be no smart contract adding so many variables as the storage set. So it is extremely secure that you will not change it if you don't do it of course in a explicit way. So this means that if your model previously created don't follow the proxy pattern, okay, you can also use it as a proxy, because it doesn't need to follow the proxy pattern. I know that this is a little change, but it is really significant if you think about it. So every smart contract has the fallback function that accepts any kind of call. And what the general purpose proxy, as any other proxy does, is just to take the singleton of the model address from the storage through sload using the same key we used at construction of the source, and using the delegate call, you just can call you the logic of your model. So you don't have to clone the entire smart contract because it is expensive. as you know. But you can use this little trick to just create this little smart contract every time, which is extremely thin, and so the cost of creating your platform is really cheaper. And you can use any kind of function, writable or readable, inside your smart contracts. So, every time you create a platform, not a platform, a model through the factory, it just create and initialize the models for you. One model or more models for you. How? Because when you pass the data, you just pass a bunch of bytes containing the deploy data. And for example, you can customize your logic inside the deploy function. Everyone knows that when you create a smart contract, maybe you need to pass some information at construction. And you cannot do it if you clone a contract directly. You can do it just if you deploy it directly. This is because when you save a smart contract inside the Ethereum blockchain, the constructor method is not cloned anymore. So if you create the constructor method, when you are deploying, the constructor method is used and then put in the trash. And the code inside the blockchain doesn't contain the constructor method. So if you clone it or using the general purpose proxy logic, you don't have the constructor anymore, and that can be a problem because you can create a contract without all the initialization variables you need to start it. And for this reason, we create also a bunch of contracts that we call, for example, lazy init capable element, which is a smart contract which is an interface that just gives you the API to lazy init your smart contract. So you clone it through the factory and then initialize it. Why? How? Using a bunch of data. So this is specific for your model. So through the factory, you just pass the data, and the factory doesn't know. Maybe it could know, but it knows is not necessary about its content. And using the lazy init method, your contract must have the entire logic used to initialize it. So, create the model, initialize it using the lazy init method, and it just is up and running in a cheaper way. So, maybe your contract or your contracts are big, you just need to deploy them one time, and then you can reuse that model several times to let people clone them and create their own application. Basic on the models you created, basic on the rules you provided, using the customization you need. And the lazy init capable element provides that they are of course overridable because it is just an interface and an abstract implementation, and you can also edit and improve them if you need. What are the methods? For example, the first method is the initializer, which is a new variable that lets you know who called the lazy init method for the first time, because they could be different. They could be the creators, the deployer of the contract, and who initialized it. That could be different. Who is the host, if provided, of your model? Who can do something special into the model? And so on. For example, if your structure is complex, you have a kind of user access control to edit or do something with your model. So think about, for example, complex structures of smart contracts.
Okay? You can have several smart contracts communicating each other, and something must be executed or set in a specific smart contract only by another specific smart contract. So subject is authorized for is used just to check, to verify if the caller is the one that can set data or edit or execute something. And what this contains: who is the subject that calls me? where is the location where this call is made. For example, there could be, for example, a smart contract access checker that receives this call and say, okay, who's calling me, at what address, what method, bytes for selector is just the selector of the function, with which data, with which Ethereum value provided. For example, if a call is payable, you can set your logic easily like this. Let's see a little bunch of code. Also, this code is overridable, so you can provide your own logic, or you can take the logic as is, but you can have a kind of cascade call of the authorization verification. So, for example, you can use the classic code and just provide something for the to delegate the control to other smart contracts or whatever. And if the control passes, it's just a Boolean. Are you able to do this? True or false? And this lets you create complex structures of access through your smart contracts. Let's see if we have something more. Okay, no. Another feature of the factory that we create is this. The deployed event. That means, for example, that in your own application, you don't, if your application lets you create several clones of your models, you have to index them into your front end, for example. And you just need to know the address of the factory you created that contains the models, and then using, for example, the deployed event to collect all the created cloned cloned versions of your model. So this means that the factory is a beacon. No more censorship inside the front end, because if you just check the smart contract directly, you have access to all data, and this is extremely important. So other data could be, for example, who is the deployer of that model, so that cloned model. So this means that who is the one that click on the deploy button and create the factory. And, or for example, could be the model address. So just let me know what is the starting model of this factory. So people can, for example, on Etherscan have access to the entire code. Another feature could be the way to know how the deploying data are made, how to pack the bytes of the deploying data. That could be because, of course, bytes can contain anything, as we know. So how can we be sure on how we need to encode the data inside the deploy method? Simply by using, for example, a specific metadata inside URIs. So you can provide, for example, an URI containing just a little piece of JavaScript code that just helps you to correctly pack the deploying the initialization data for your application, for example. And you can provide it in two ways. The static way, so for example, providing a link on ePFS, as we already know, or build them dynamically. In fact, we created the dynamic metadata and provided for you in order to let you create the metadata dynamically based on context if you want. And I'm going to show you this dynamic metadata. Dynamic metadata capable element is just an interface that implements the lazy init capable element. So you could have a normal model or model provided with metadata that can contain, as I said, for example, the data used for creating or just providing information about your factory and your model, etc. And it just as classic method. URI and plain URI. What this means, what is the difference between them? URI can contain URI, of course, dynamically created. For example, providing the entire metadata, not just a link, but the entire bunch of data encoded in base 64. So all the logic we provide is just, for example, here we have the renderer, which is just a method that you can fill with your own logic to write down your JSON and then encode it in base 64 and provide it as is. So no more centralized links anymore. Everything is on data. And the resolver does the magic for you. I want to take a look to the URI resolver. So if when you create a URI, when you ask for a URI, the internal method just calls the URI resolver you provided. And the URI resolver, we created a general purpose version, just try to resolve it calling the renderer you wrote. So if it has success, it will give back the rendered URI. Or if the operation don't have success because, for example, there is an error in the data passed or you don't have a renderer anymore, you can just pass the plain URI. So maybe you chose to do not have a dynamic metadata, but just classic URI where to grab the metadata. So let's take a closer look at the factory. The factory just manages a single model to clone, but as I said, you can provide your own version of the factory basing on the skeleton and just use the lazy init method to create your own models cooperating each other. But this is just one factory. What if, for example, your model needs to be updated? You can specify specific access control in order to be able to change the model, but as we said at start, it could be dangerous. So the best way is to seal everything and just use a system that versions your factories. So you have factory versions 1 using model version 1, factory version 2 using another model or another way to create, etc., etc., etc. How to manage this? Using always the same concept of just one address to save in your front end, let's say, and grab all the data directly from the chain. We created the concept of factory of factories. So once you create your model, you create your factory, then you can call the factory of factories just to index all the factories linked to that project, for example. So you can create a new factory passing the bytecode. The factory of factories will create the factory and store it into its storage, and you can as in the way using by the factory, just index them. If you need to update your factory, you don't have to update that factory, but you can create and add a new factory to attaching it to the previous one. So when you create a factory or a bunch of factories, every factory will have a position in the list of the factory of factories. And then you can use that position just to add another factory to that list. So this means that you don't have to save the factory address anymore. You just need to save the factory of factories of just the factory of factory address, which is a singleton created for you. And you can use it, and just using the list positions we provided you when you create your own factory through the factory added event, just to have all the factories of your application, and just use them to list all the models created with versioning. And this is extremely important and totally censorship resistant, if you think about it. For example, you can provide also a way, because of the factories could be, just give me a second, could be payable. For example, you can also provide a logic to let people pay to clone your own models. So you can create your own business on it if you want. And if you can use the factory of factories environment, you can also have a lot of APIs just to help you to set up your economic logic. So everything is already done. We, as I said, put the math, and you put your logic, put the love, as we said. Okay. So let's go back to the slides again. So, as in the Web 2 platforms, the platform provides you everything, provides you a set of rules you must follow to create the applications. And people can use these factories, these platforms, to build their own entities based on the rules that you provided. And this is with their own governance and their own economies, for example. And this means that creating a platform means creating a nation, having their own businesses. So you provide the generic rules that all the entities must follow, okay, the fundamentals, and then all the application built on them will automatically follow that preset choices you provided to the users. So this means that, like in the countries, this is how countries work, if you think about it. So the platform could be it could be a nation, if you think, or, as we said, a non-nation. To talk about non-nations, we invite you to stay tuned on our speech by Aletoshi tomorrow in the next session, tomorrow during its session. So thank you very much. I don't know if you have any question. No questions? Okay. So we can take, for example, a closer look to the code of the lazy init, how the lazy init and the initializer work. So, for example, when I deploy a contract using the deploy method of a factory, the factory internally calls the initializer, which is a library. What the initializer does, it simply calls the creator library. Let's take a closer look to the creator. The creator just uses the general purpose proxy. So to the creator, you provide the source address of its bytecode. So for example, if it is the first time to create, you creating a model through a cloned application through your model, it could be also the first time your source code is created. So you can provide at the same time the address of the model of its bytecode just using the bytes data. If the bytes data is an address, it must be used to initialize the general purpose proxy to create it. Or you can just use the create low-level API into Solidity assembly to create the source at start, and then use it to create a general purpose proxy, passing the source code. Also using also passing ethers to create it. So, as we said, the factory calls the initializer. The initializer calls the creator that creates your cloned model that we call destination, and then the logic just call the lazy init method through calling your destination. So this means that you don't have to use a constructor inside your model, but just implement the lazy init method that I showed you before, which is the one of the lazy init capable element, just to create and initialize your application by cloning it and without directly deploying it. What this means that the created method is raised by the factory itself. So you must just stay tuned for the events of the factory, and you can, for example, fill up your front end directly without saving anytime all the addresses of the cloned applications that people clone. And this could be a huge help for filling all the entire logic. Okay, so let's see what we can offer to the lazy init capable element. For example, it supports the RC 165 that lets you, for example, declare all the methods provided by your model. So you can check, for example, if your model, like for example, as a specific method, the supports interface will tell you. You can provide the logic to set the host who has special permissions inside your models through using just a user access control. So no one must be able to change the host, but only the authorized smart contracts or authorized addresses, if any. And the subject it's authorized for will provide the logic for you. And for this reason, we created also a modifier called authorized only that that any method can use of your model just to provide the logic to check if the subject that is calling the msg.sender is authorized to do that call for you. Just passing the data of the call. So it is the msg.sender, the signature of the method you're calling, the entire payload of data, and, if any, the Ethereum that you provided. Okay, let's see what can just... we also provided method to be compatible in a really easy way with Optimism and EVM and classic mainnet Ethereum. What is the only difference actually between Optimism and Ethereum? The way you retrieve the block number of the mainnet, because when you have to take the block number on Ethereum, you just call the block.number API on EVM. But we know that everyone knows that in Optimist this could be not possible, because if you call block.number, you are calling the number of the Optimism chain. But if you need on Optimism the block number of the mainnet, you can just use the Optimism API. Optimism just provides you the address to call to retrieve the L1 block number. So this can help you to write a simple logic just to retrieve the block numbers from the Optimism to from Ethereum mainnet to Optimism mainnet L1, let's say. Let's take a closer look on the resolver of dynamic query. So dynamic query resolver must be just a singleton contract, so not be necessary to deploy it, that can call the resolver if any, or just retrieve you the plain URI. And the logic of the resolver, the renderer of the logic, could be written directly by you, and it returns just a string containing the metadata of your logic. And to let you be the easiest as possible to create your own metadata, we just provided to you a bunch of utilities that you can use. For example, let's see if I found something here. For example, to convert an address from byte address to string in order to provide it inside your metadata. Or numbers, for example. So you have a number and have to render it as string. We just provide you the entire logic you can use to do that. Or, for example, the conversion to base 64. So when you have to create a dynamic metadata, you just write your JSON, let's say, convert it into base 64, and then attach just the base 64 data that you can use to transform it in a local URI. So with all this stuff, you just call into your front end, just query the link that we provided, but the response is already into the link. So it just render itself without calling any kind of external source. So this is 100% censorship resistant. Okay, guys, I think that for me is enough. If you have any question, I can respond to you. No one? Okay. I think